Hey, look, guys, it's identities. Okay, you guys are going to have a full sheet of these things. So when I go through and talk about what these are, you're going to have all of your trig identity sheets to be able to look at and figure out what's going to happen. So I'm not concerned about it, but I do want to make sure that you have an opportunity to go, oh, I know what to do. Okay, so that being said, you're ready. Here we go. These are actually not terrible. Actually, none of them really are too terrible as we're looking at it. So that first one, secant x minus tangent x sine x is equal to 1 over secant x. Again, we take the more complicated side, make it look like the right. I do want to do something for just a second here. This is the only one of these that when I look at, I'm like, dude, really? What fool? No, I'm just kidding. This is the way that a lot of these things are going to get written. And most of the time, we are not going to work both sides at the same time. So I'm not going to do that, but I want you to note, we don't ever really write 1 over the secant x. So what I want you to do is to think for a second. This is just the reciprocal of the secant. What you're going to be looking for is the cosine of x. And the reason I want you to look for that is because it's like the writers of this said, I want to add one extra step just to make it a little off. It's kind of dumb. So I want to make sure that you see it because we're going to have to make a step like that as we go. All right. What I would do is I look at the left is say, all right, we got secant, tangent, and sine. This doesn't really fit anything we have right now. So let's just throw it all in terms of sine and cosine and see what we can do. Secant is 1 over cosine. Tangent is sine over cosine. Now, I'll tell you what I love about that. Common freaking denominators. That's going to work great. Now, sine is already there. So I'm just going to put that here over 1 because I have a common denominator. So when I do this, this means I will have 1 over cosine x minus sine squared x over cosine x. And then if I put them together, I will have 1 minus sine squared x over cosine x. Now, 1 minus sine squared should be ringing out in your head. You should be going, oh my God, I know that. Because 1 minus sine squared is just cosine squared x. Well, holy crap. I got cosine up, I got cosine down. There's 2 of them up here, there's 1 of them down here. That means it'll cancel out and just give me a straight up cosine. Wait. We were going to go for that from before because I know that the cosine is just equal to the 1 over the secant of x. Hey, we did it. Now, the heavy lifting here is basically can you remember that that's the cosine x? Everything I did here is pretty straightforward, and we're not going to try to confuse you on the final with what we're doing for these, but I do want to make sure that you kind of have your head on straight for it. So that's the process that we went through to follow them. This one to this one is a big one. The Pythagorean identities get used a lot. All right. Next, we now have 1 plus the cosine of x over the sine of x is equal to the cosecant of x plus the cotangent of x. Now, you can pick whichever side you want. I believe that what I am going to do is pick the one on the right, just because it looks like there's more of them here, and I think I could probably end up with here. This is all in terms of sine and cosine. This one is not. These should be pretty easy to make into that. So let's see what we can do. This here is 1 over the sine of x. Cotangent is cosine over the sine of x. That is a common denominator. Look what happened. Okay, so now sine of x is the denominator. 1 plus the cosine of x is the numerator. I now have made it equal to the thing that I started with. If you were going to start on this side, you'd split it up into 2 separate fractions with this denominator, and then it would become. So this is a pretty easy one, which is good. We like easy. Easy makes it simple for us to kind of move on. Okay, so that's what we got to do for that one. This one, well, all right. So we got cosecant squared theta, tangent squared theta minus 1 is equal to tangent squared theta. Clearly, we're starting on the left because there's more stuff happening. My handwriting has gotten worse every time I've done this, so let's make it so that it's going to look better. Let's do our sine and cosine fun because I think that's going to help us out. Cosecant is 1 over the sine squared theta. Tangent squared is sine squared theta over cosine squared theta. And I'm going to keep my -1 here. Guys, look at the magic. Multiplying fractions, we got the same thing on our diagonals, which means that that and that will cancel when I multiply. I will then have 1 over the cosine squared theta minus 1. Don't know if you remember this, but 1 over the cosine is the same as the secant. So secant squared theta minus 1, that actually is one of our Pythagorean identities. This is equal to the tangent squared theta. And that is what I wanted to have it work to right there. So, hey, we got it. Look at us. Okay, there's only 2 left. This guy right here, secant squared theta over secant squared theta minus 1. We want that to equal the cosecant squared of theta. Now, we just did this. Secant squared theta minus 1. We know what it's equal to because it was literally the last problem. So what I'm about to do is the quick change of that to a tangent squared theta. Secant squared theta over tangent squared theta. Now listen, some of you see that and your mouth is starting to water and you go, I can cancel it out. But remember, if I have a subtraction here, I cannot cancel. I could split it into 2 fractions if that was on the top, but since this is in the denominator, there is nothing to split. So doing the substitution here makes the most sense. Now, let's write them all in terms of sine and cosine and see what happens. This top one is going to be 1 over the cosine squared theta. The bottom is going to be sine squared theta over cosine squared theta. And so when I look at that, I think fraction on top, fraction on bottom. Let's flip the bottom and multiply. So we will have 1 over cosine squared theta from the top times the reciprocal of that is cosine squared theta over sine squared theta. Guys, look, look. Our favorite thing, those go away. So this is just equal to 1 over sine squared theta. I don't know if you remember this. 1 over sine is the same as the cosecant. So I could just say that this is the cosecant squared theta. And that is what I was trying to get to. Yay! Guys, one more. All right. Cosecant theta times parentheses tangent theta secant theta minus sine theta. Hey, guys, I bet we're going to be making this in terms of sine and cosine is equal to tangent squared theta. Man, anytime that it's like this crazy secant, cosecant, tangent stuff, you're always going to do it in terms of sine and cosine and seeing what comes up, okay? So I'm giving you that as the advice because holy crap. All right, 1 over sine times, that's going to have to distribute. This is sine over cosine. This is 1 over cosine. And I'm just going to keep this one as sine theta because that's in terms of sine and cosine. So if I distribute this, give me a second. Let's put this together. Sorry. 1 over sine theta. I don't really like having the 2 here because if I distribute in my head, I'm going to try to put it to both, and that would just be, this will be sine theta on top, cosine squared theta on the bottom, and then minus sine theta here. Okay, now I can distribute this here and this here. When I distribute this to this one, the signs will cancel out, and I will have 1 over cosine squared theta. That's from that first one. When I multiply this times this will be sine over sine. They will cancel out and give me just 1. Now, if I remember, 1 over the cosine squared is equal to the secant squared of theta. And holy friholies, this right here, by the way, those are beans, friholies. I don't know. It seemed fun to say right there. We just did this one knowing that there is an identity that makes that tangent squared theta. We've used that one a lot in this set of things. That's kind of the way a lot of these things do. They sort of sit into groups. So we've done this to here. Check, guys. We did all of the trig identities. Woo! I'm gonna stop sharing and say to you, you're doing great. That's the 6th video. We're kicking butt, taking names. We got the whole 2nd page done. Wait until we go to the 3rd page. It will be magical.